Welcome to this class. In this session, we are going to give examples on how to carry out implicit differentiation. So the first example, find dy dx if y squared is x. Okay. Solution. We have the equation y squared equals to x. So if you remember the steps we gave on implicit differentiation, step one is to supply d dx on both sides. So d dx and then d dx. Now using power rule, this will give us 2y, but y is assumed to be a differentiable function of x. So you attach dy dx. d dx of x is just 1. So next step is to make dy dx the subject, and you do that one by dividing through by 2y, so which means dy dx is given by 1 over 2y, which is the same thing as saying 1 over 2 square root of x, since y squared is x. So it means that y is square root of x. You can say plus or minus x. And then example 2, find the slope of the circle x squared plus y squared equals to 25 at the point 3, minus 4. So it's simply to get dy dx, and then you substitute the value of x 3, value of y negative 4. So solution, we have x squared plus y squared equals to 25. Step 1 in implicit differentiation is to supply d dx on each term or both sides. So we have d dx of this, d dx of this term, and d dx of this term. So by power rule, this will be 2x. Power rule, this will also be 2. This will be 2y. But remember, y is taken to be a differentiable function of x. So 2y, but you attach dy dx. Derivative of a constant is always 0. Now we have 2y dy dx. Take this other term to the right to be negative 2x, and dy dx will be simply given by dividing both sides by 2y. So this and this cancels out. This will be negative x over y. So the slope at 3 minus 4 means dy dx at 3, minus 4. Where does x put 3? We have negative. Where does y put minus 4? Negative cancels, and then we get 3 over 4 as the slope. Number 3, find dy dx given that y squared equals to x squared plus sine of xy. This is an interesting problem. So what you do first, you write y squared equals to x squared plus sine xy, and then supply d dx on each term. So d dx, d dx, d dx, just step by step. And then d dx of y squared, by power rule you get 2y, but because we are dealing with y, which is assumed to be a differentiable function of x, you attach dy dx. This by power rule is 2x plus. Now here, you ask yourself, this is a sine function. Forget about the argument of this trigonometric part. This is a sine function. So when you differentiate a sine function, you need to get a cosine function. So you write cos of xy. And then now you differentiate this part, this by chain rule. So d dx of now x, y. And then next step. So here, remember, it's a product of two functions. So this will take it to be u, this will take it to be v. So you lose u prime v plus v prime u, product two. So this will give you 2y dy dx equals to 2x plus cosine of xy into, so u prime d dx of x times v, which is y, plus v prime is d dx of y times u, which is x. So we'll have 2y dy dx equals to 2x plus cosine of xy into d dx of x is 1, so times y you get y, plus d dx of y is 1 times dy dx, because this y is assumed to be differentiable function of x. So dy dx times x, we get x dy dx. Now next step, you open the brackets, so we have 2y dy dx equals to 2x plus y cosine of xy plus x cosine of xy dy dx. Now, usually the next step after doing the derivatives, you collect terms with dy dx. So take this term to the left. We'll have 2y minus x cos of xy, and then dy dx equals to 2x plus y cosine of xy. And then our interest is to find dy dx, so divide through by this bracket. So y minus x cos of xy divide 2y minus x cos of xy. So this and this cancels out. So it implies that dy dx is given by 2x plus y cosine of xy divided by 2y minus x cosine of xy. So that is the solution to that given problem. Lastly, given that two x power 3 minus 3 y squared equals to 8, find d squared y dx squared. Let's simply find the second derivative. Now what to do, you get the first derivative and then use the first derivative to get the second derivative. So solution, we have 2x cubed minus 3y squared equals to 8. Step 1, we supply d dx on each term. d dx and then d dx. That's step 1. By power rule, this d dx of 2x cubed will be 6x squared minus power rule here will give us 6y. But then because there's a y here, you attach dy dx equals to 0. Derivative of a constant is 0. So this tells us that 6y dy dx is equals to 6xy. Now to get dy dx, will be just divide through by 6y, divide through by 6y. So this one. So this tells us that the first derivative of this function dy dx is 6 and 6 cancels, x squared over y. So this, for this to be defined, we specify that y should not be 0. Now, to get the second derivative, we usually differentiate the first derivative. And so we use, this is u, this is v. So we use quotient rule. So d squared y dx squared will be u prime v minus v prime u over v squared, which will be u prime, differentiate this one with respect to x, you get 2x, and then multiply by v, 2xy, minus, differentiate this one with respect to y, so you get 1 times dy dx, so you have dy dx, and then times u, which is x squared dy dx, and then divide by v squared is y squared. And you see this is the same as 2xy over y squared minus x squared dy dx is the same as, from this equation, is x squared over y, and then you are dividing by y squared. So here we have 2x over y minus, so this will give us x power 4 over y divided by y squared. So which is the same thing as writing 2x over y minus x power 4. So when you say x power 4 over y, divide y squared, is simply x power 4 over y times the reciprocal of this is y squared, 1 over y squared. So x power 4 over y power 3. So over y power 3. So this is the second derivative of that function given. Thank you.